The idea is, try, it's made up of 3 words. What does try mean?
3.
Good. So it's made up of 3 things. It's made up of 3. Do you know what gone means? It's a Greek word, it means angle, okay? You might have heard of polygons, okay? Poly means many, gon means angles. They're literally talking about shapes, okay, with angles in them. Now, ometry, it's kind of got the word metry in it, metric. It literally just means measure, okay? So, if you kind of look at the meaning of the word, kind of what the word is made up of, it literally means 3-angled measure. In other words, you're looking at the measure of things with 3 angles in. Well, are you happy? Things with 3 angles in are just triangles. So what trigonometry is all about, it's all about measuring triangles. It's all about looking at the features of triangles and trying to understand triangles a little bit better. Now, triangles are great, okay? I can't really emphasize how great triangles are, because triangles are like the building blocks for all other shapes, okay? They're the first shape that you meet, okay? They're the first polygon that you meet, because of course you have to have a minimum of 3 sides and 3 angles in order to define a shape, in order to have a closed 2-dimensional shape, okay? You can't have 2 angles, because if you have 2 angles, well, okay, there's one there, and there's perhaps one there, but it doesn't then form a closed shape, okay? So you have to have 3 angles and you have to have 3 sides in order to form the first basic 2-dimensional polygon, 2-dimensional shape. And actually, all other shapes are made up of triangles. For example, if I draw something like this, which is some weird and funky, what's that, 1, 2, 3, 4, 5, weird and funky pentagon, okay? I'm able to find triangles hiding within this. And the way which I can do that is just simply drawing in lines, like so, and like so, and I have 1, 2, I have 3 triangles, okay? So what I'm trying to show you then is that triangles make up every other type of 2-dimensional polygon. Okay, so triangles are literally everywhere. If you understand triangles, you pretty much understand any other type of shape as well. Okay. But I can actually break this down further, because I don't just look at any type of triangles. Do you know what different types of triangles there are?
The 90-degree one.
Good, so which one is that called? It's called a right angle triangle. So it's literally a triangle with 90 degrees in. Do you know any other types of triangles?
45, 45. Wait.
45, 45, 90, that's another right angle triangle.
No, not that one. 60, 60.
Okay, so 60, 60, 60, okay? So in other words, all angles are equal, and we call that an equilateral triangle. Do you know any other types of triangles?
30, 30. That's 120.
120, fantastic. So we would call that type of triangle, that's one example of an isosceles triangle. Oops, isosceles. Okay, that's basically where you have the 2 angles at the bottom the same size, 2 sides each side the same size, but then the other 2 side and angle are different. Okay, there is one other, do you know? So it's basically where all the sides are different, all the angles are different, we call that scalene. Okay, so these are the 4 real basic types of triangles which you can have, okay? And the idea is that all other shapes are made up of triangles, so if you can understand these 4 types of triangles, great, you're in business. But actually we don't even need to understand all 4 types of triangles. Actually, all triangles are made up of right angle triangles. Okay, so right angle triangles are kind of like the basic fundamental building block of all other shapes. Because triangles are the building blocks for all other shapes, and every triangle can be made up of right angle triangles. For example, look at this one. This is a triangle, okay? This could be, well, it could be equilateral, but I think it's probably more like, scalene, to be honest with you. But the idea is, if I just drop a line down here, which is perpendicular to the base, I've got myself 2 right angle triangles there and there, okay? So I love triangles, okay? Right angle triangles are kind of like the basic building blocks of all other types of polygons. So if you can understand right angle triangles, you understand all other types of polygons, which I think is a really powerful kind of thing to notice. Okay, so let's draw ourselves out a right angle triangle then. And in fact, I'm going to draw out 2 right angle triangles, okay? So this is my first one. So I'm going to put my right angle down there. And I'm going to draw out an exact same copy of this. So it's exactly identical. We say it's congruent if it's exactly the same. I mean, yeah, it looks about the same. I think that's believable. Okay. Now, are you happy that because I've taken one of the angles to be 90 degrees, there's actually only other 2 types of 2 angles that can change? So the other 2 angles are variable because that angle has to be fixed because I'm looking at a right angle triangle. Okay. So actually, I just need to focus on the 2 remaining angles. Let's focus on, first of all, this angle down here. So I'm going to call this angle alpha. Okay, so I'm going to give this a special name. As a general rule of thumb, we don't always do this, but as a general rule of thumb, we tend to give angles Greek letters. Okay, so alpha is a Greek letter, so I give that an angle. Okay. In actual fact, just because this triangle is exactly the same, well, this triangle I'm focusing on this angle down here. In this triangle, I'm going to focus on the other angle. Okay, I'm going to focus on this angle up here, and I'm going to give this a special name. I'm going to call this one beta. Okay, so we've got alpha and we've got beta. Okay, good. Now, the idea is, with right angle triangles, there are 3 sides. And I can label these 3 sides in relation to which of these 2 angles I'm looking at. Okay? So if I'm looking at this angle down here, okay, well, the side opposite the right angle, are you happy that that is always, regardless of what the angle is or what the other sides are, that is always got to be the longest side?
No.
Okay, so think why, okay? This side is always going to be the longest side because it's a triangle inequality. So basically, if you take this side and this side has always got to be the longest side because this angle has always got to be the biggest angle, okay? Regardless of what these other 2 angles are, they've got to add up to, all angles in a triangle have got to add up to 180 degrees. You happy with that? Well, if one of those angles is taken as 90 degrees, the other 2 angles have got to be less than 90. You happy with why? Because they've got to add up to 90, haven't they? There's only 90 degrees left. So because there's this relationship between side lengths and angles, the angle will dictate the side length. The bigger the angle, the bigger the side. Okay? So because this has got to be the biggest angle in the triangle, in the right angle triangle, this has got to be the biggest side. The side opposite's always got to be the biggest side. Okay? So if this was made smaller, this side would also be made smaller. If this was made bigger, this side would also be made bigger as well. So that's kind of the fundamental principle of relationships between angles and side lengths. Okay? So because this side has always got to be the longest side in a right angle triangle, we give it a special name. We call it the hypotenuse. And in fact, this angle is this right angle triangle as well. Well, that side is still going to be the longest. So we're going to call that the hypotenuse again. So the hypotenuse is always the side opposite the right angle triangle. Sorry, opposite the right angle. It's always going to be the longest side. Okay. All right, fine. So what else can we notice then? Well, are you happy? Are you happy if we just focus on this triangle here for the time being? In other words, we're looking at it in relation to this angle down here. Well, this side is opposite the angle that we are interested in. Okay? So we call that side the opposite. Okay? So we call this side here the opposite. And because this side is kind of next to the angle we're looking in, okay? Obviously the hypotenuse is next to it as well, but we've already got a name for that, it's the longest side. So because this side is next to the angle we're interested in, we call it adjacent. So adjacent just means next to, okay? So the opposite and the adjacent side is always given in relation to the angle which you're interested in. Not the right angle, the angle which you're interested in, this one or this one. Okay, so in this case we're interested in red angle, that's the side opposite that red angle, so that's the opposite side. And this is the red angle we're interested in. This side is next to or adjacent to that red angle, so that's called the adjacent. Okay? And the hypotenuse is always the same. It's always the side opposite the right angle. But if we look at this triangle, so remember these two triangles are congruent, they are completely the same. It's just we're looking in terms of different angles. So this triangle was looking in terms of this angle down here. This triangle was looking in terms of this angle up here. Could you tell me what we would call this side then?
Opposite.
Perfect, because it's the side opposite the angle we're interested in. And what would we call this side here?
The near one.
So the adjacent. Fantastic.